Hi, and welcome to this STAIR Tailored. I'm Erica Mason from the University of Missouri. Today's video is the last video in a 5-part series about how to factor quadratic expression. And the specific topic of today's video is how to help students establish and understand that the equivalency between quadratic expressions and their factored forms. Before we get into this, let's talk a little bit about the foundation upon which this work is built. There are 3 primary ways of representing mathematical ideas: concrete, pictorial, and abstract. At this point, we're really trying to help establish comfort and flexibility with working in the abstract form. So the purpose of today's lesson, like I said, is to really establish that the expression, the quadratic expression, and its factored form are equivalent, right? And so there's lots of ways to go about showing this to students, and here's what we're going to suggest to you. So you might pose this problem to students. The area of every classroom in the school is x squared plus 2x minus 8. Fill in the table to represent the areas of each specific classroom. So by giving students this quadratic expression, that assumes that students at this point already feel really comfortable with multiplying those factors to get this quadratic expression. So once they arrive here, you're going to invite students to plug in the values of x and to come up with the areas for each classroom, right? What you're doing here is you're establishing that this expression is true for these x values. By giving students this quadratic expression, we're assuming that they're already comfortable and proficient in multiplying linear expressions to have arrived here. And now we're going to use this expression to figure out what its factors are. So first, I'm going to use this table or this box method to really help me organize and make sense of this problem. So I know I can go ahead and put in here my quadratic term, which is x squared. I also know that I can go ahead and fill in my constant term down here, which is negative 8. Now all that's left is for me to really figure out what to do about this linear term. So if I know that my constant term is negative 8, that means I need to consider what are the factors of 8, and I'll take that negative into account in just a minute. So first I know that the factors of 8 are 1 and 8, and 2 and 4. So once I've established what my factor pairs are, I can now consider this linear term, this positive 2. So I have to ask myself, which factor pairs are going to be able to sum to positive 2? So first I consider my 1 and 8, and I think, is there any way for those 2 factors to sum to positive 2? And the answer is no. I then look at 2 and 4 and ask myself the same question. Is there a way for those 2 factors to sum to positive 2? And there is. And so that's where I'm going to have to think about, how is that possible? Well, you can either think of it as 4 plus a negative 2 or 4 minus 2. So I've established now my factors. 1 is going to be negative 4. Oops, excuse me. 1's going to be positive 4, and 1's going to be negative 2. So now I have most of my table filled out, and I can fill in the rest. So I have to ask myself, how did we get this x squared? Oh, by multiplying x by x. I can then now ask myself, what is 4 times x is 4x? And I can ask myself, what's x times negative 2? That's negative 2x. All of this table is going to do now is help me make sense of what my factors are, right? In these dark blue rectangles here. Once students have used the box method to come up with the factors, you're going to revisit your original expression and this original data that is connected to that contextualized word problem. So you can now fill in this answer here, right? X squared plus 2x minus 8 is the same as or equal to the factors x minus 2 times x plus 4. Now you have another opportunity for students to see equivalency. Students have already taken these x values and plugged them into this original expression and found that they come to be true or to be valid in solving for the area. You're now going to invite students to do the same thing but with the factored form. So you're going to invite students to use these x values, plug them into the factored form, and see if they get the same answers, which they should. This is also a really awesome opportunity for you to engage students in a conversation about their understanding of the equal sign. Again, the point of this lesson today was to really establish equivalency between these two things, but students might still have misconceptions about what that equal sign means. So you can remind them that the equal sign is really just a symbol for the same as. So if you were to read this number sentence, it would translate to x squared plus 2/8 minus 8 is the same as x minus 2 times x plus 4. Thanks so much for watching this tailored video. If after watching this you think your students could benefit from additional instruction on multiplying linear expressions, be sure to check out our other tailored video series.